In this session for business analysis, we're going to be looking at contingency tables, creating them using pivot tables, as well as chi-square analysis for independence. We're going to be using an example to work on this, and more will be covered in class. So when we look at these, let's go ahead and look at a company. ABC Fitness Company has just finished doing a survey. And in their survey, they've asked a series of questions and have a series of values that they've placed with different pieces to it. And the people in charge of the exercise programs are really curious if men are more satisfied than women. Is there a dependence on if a person is male or female to how satisfied they are with the exercise program? There are many ways to do this test, but this might be a simple way to go ahead and see, can we do more digging in and more tests afterwards, but which ones come to light just at the top level then. So those are the two we want to compare. So we want to compare gender against exercise program satisfaction. If we look at the description tab, we'll find that 1 is male, 2 is female. We'll also find that 1 is very dissatisfied, 5 is very satisfied. So let's do insert. First of all, let's click somewhere in the region. Insert pivot table. It's going to say, is this the area you want? We're going to say yes. It'll add it to a new tab. So we're going to put gender along the top. I do not want to have grand totals in mind, so I'm going to go to design up here and turn off grand totals. Next thing we're going to do is we're going to look at exercise program satisfaction, and we're going to want to count everything out there without us having to actually count. So since this is gender, we're also going to pull gender down to there, but notice it says sum of gender. So we're going to want to change that to count of gender. That makes more sense now. So what we found is this is male and this is female. This is, let's go ahead and change the size of those. This is very dissatisfied, neutral, satisfied, and very satisfied. Because if we start working with this, and this is already in pivot table format, we're going to run into challenges. So I'm going to suggest that we go ahead and we copy this section of it. So Control C, we go to a new tab and we paste on the second row down, and we're going to paste values. And now we're going to go ahead and look at our data without the pivot table portion of it, and we can do some analysis on it then. So in looking at that, let's go ahead and put boundaries around this so we can see that. And let's go ahead and put totals out here. So here's your auto sum, and we are now auto summed on that one. So this was our observed values. So the hypothesis test that we're going to run is that gender and exercise program satisfaction are independent. Our alternative hypothesis is going to be essentially the same, so I'm just going to copy that. The opposite of independent is dependent, so let's go ahead and put that there. And we're going to work on that presumption. So if two things are independent, one of the things that is true about them is the probability of A and B is the probability of A equals the probability of A times the probability of B. So that is a true statement when things are independent. So we're going to test if that's a true scenario. Because we're working with 1,184, we're going to multiply that by our probability. So without going into all the math pieces that go along with that, we're going to basically go into here and say, let's not have them quite as large as that. And we're going to look at this one and we're going to take out our values and we're going to put an expected value here. So our expected value has to do with the fact that we've said that they're independent. So we're going to take the fact that the total of the very dissatisfied and the total of the males, and we're going to divide it by the total of the whole group. So the calculation on here is this times this divided by this. So D3 times D8 divided B8 divided by D8. Because with this independent piece to it, we would expect to find 47.7, and we observed 47. So that's fairly good on that one. When we try and copy that same formula to all of the other ones, there's a pattern that goes along with it. You're always going to go to the column D. You're always going to go to column B. So on this one here, if we notice D8 is your one you want to definitely lock in for all of them. But you can also lock your D and you can lock your 8. So you're always going to go to column D. You're always going to go down to column 8. So when I multiply this one, or when I copy this one all the way across, what I find is I now have the same totals. And I have the same column totals as well, but my values on the inside are different. So I would expect to find 47.7 and I observed 47. I would expect 109 and I found 110. I would expect 73 and I found 80. So we're starting to see a little bit of differences between the two of them there. So the calculation that we're going to do on this one is we're going to go ahead and we're going to copy this one over here now. So let's copy this. And I should have done it as paste values, which is why it yelled at me. So now that I've done it as paste values, I'm going to go ahead and clear that section out because I need to do this. Your calculation to figure out your chi-square value is observed minus expected squared divided by expected. So how can we make that happen? So, and these totals need to go away, don't they? So it is going to be equals observed at 47, males and very dissatisfied, and expected, same category. We're going to square that and divide it by the expected category. We're going to do the same thing for females, so it means we're going to go up to our observed minus our expected squared. But when I do that, I essentially can just copy this one formula all the way across without dollar signs because I want them all to move. And I'm going to find that when I do that and then do my total, I'm going to come up with my chi-square value, and it's going to add it all together for me. So I have now found my test statistic. So this is my chi-square test statistic. Let's go back a little bit to hypothesis testing for a moment. I need to have a rule here, don't I? So I need to have a decision rule written. So my decision rule is reject H sub O if I'm going to do a chi-square is greater than. So how do I find my rule here? So the problem, we were told that alpha is 0.05. So our degrees of freedom is the next thing we need to figure out on a chi-square. So that's going to be your rows minus 1 times your columns minus 1. So I have how many rows? I have 1, 2, 3, 4, 5. So it's going to be 5 minus 1, which is 4. And my columns is 2, 2 minus 1 is 1. So my degrees of freedom are 4. So reject h sub o of chi-square. So we can enter this in the system one of a few ways. So you can do, I put an apostrophe in the beginning, so it's going to treat it as text. So equal chi-square dot inv dot rt. So if you're using Excel 2010, you can do 0.05, and your degrees of freedom is going to be 4. If you're using an older version, you can type in equal chi-square dot inv, chi-square inv, I believe it is, .95 comma 4. So let's try both of those out. So equals chi-square dot inv dot rt, probability 0.05 comma 4. Get 9.48. So if I do one of the older formulas, chi-inv 0.95 comma 4, don't get the same one. So let's do 0.05. I get the same value there. So the formula in the older version is that one right there. So next, if our test statistic is found to be above 9.48, we're going to reject h sub o. Well, we did our test and we found that chi-square was equal to 3.81. So therefore, based on our decision rule, our decision is to do not reject h sub o. There is insufficient evidence to show that gender and exercise program satisfaction are dependent. So there's not enough evidence to show that there's a relationship there. So having said that, what's our business conclusion on this one? Since it's a do not reject h sub o, we're going to move forward with it, and we're going to say that they're independent. So it doesn't matter whether you're male or female on how you rated the exercise program. So there is no evidence to show that a person's gender influences their satisfaction with the exercise program. At ABC Gym. So if you're coordinating the program, I would think that I would probably add something to that, something along the lines of, therefore we must be offering enough of variety so that men and women are both satisfied with the programs that we offer. So that's one example of doing the contingency analysis using pivot tables. Essentially, anytime you can come across an example where you can have a type of machine, so let's say A, B, C, and let's say their defect, right? So defect A, B, and C, and D. So there's 4 different defects that can happen. And if you have some values that go along with them, so 14, let's say 34, let's go there, and And so if we have this, we would be able to see if, depending on the type, is there a specific defect that affects one of the types more than the others? Is there a relationship between the type of product and the defect that's out there? So anytime you have one relationship compared to another, you can do those. So quick and dirty on this one, go ahead and put in your values, sum them up. I would do a quick copy, copy, and copy. So we're going to insert on this one. This is our observed. This is our expected. So H sub O on this one is that product type and defect are independent. So we're going to do H sub A. Opposite of independent is dependent, so let's go there with it. So we have observed, we have expected, so we're going to have to figure this one out. Let's go ahead and take those out. So this one's going to be your observed minus expected squared divided by expected. So on this one, I have product type A, so I want to do the total of A divided by the overall total. Because that one is E8, I'm going to go ahead and anywhere I see an E, I'm going to put in a $sign. Anywhere I see an 8, so I have E8 locked in. I have column E and column 8, so it's always going to go to our totals to figure these out. I can now copy all of those across. Then if we're going to go next here, we're going to say then that it is my parentheses observed minus expected parentheses squared divided by my expected value. Because I want this to be able to move, I can copy these all the way across. So my rule in here would have been reject H sub O if chi-square is greater than. So I'm going to say that my alpha value was 0.05 and my degrees of freedom are always my rows minus 1 times columns minus 1. So rows minus 1, so 4 minus 1 is 3, times column minus 1, so 3 minus 1 is 2, which gives us a total of 6. So equals chi-square dot inv dot rt of 0.05 comma 6, or if you were on the older version, it would be equals chi-inv 0.05 comma 6. You would have got this, not 60, 6, you would have got the same value. My chi-square value that we came up with was chi-square was equal to 35.184. It is bigger, so because it is bigger, we're going to reject H sub O. So if I'm going to reject H sub O, I'm no longer going to go ahead and use that one. So let's go ahead and do a strike through on that one. You don't need to do this, it's just more for visual effect. So we have shown that product type and defect type are dependent. There is a relationship between the product type and the defect type. So where are my strongest relationships in there? So if anything bigger than 12.59 flagged me, and I look at my values on the inside, where is it that I am significantly highest? So I would think my highest value is here, so there's 11. So I was expecting to find 25, and I found 43. So product C seems to be more likely to have a defect type A. The next one that we found in here is product A. I was expecting to find 27 and I found 14. So it's the opposite one on that one. I'm not finding that defect in product A. And then on product C, I was expecting to find 29 and I found 43. So in product A, I am finding more of defect type C. So these aren't conclusive by themselves, but it starts to tell you a story about where you might start looking for your defects and digging down into your data a little bit further. Again, I hope that helped, and I'll catch you in the next lesson.